So, welcome back again. In this part, we will mainly focus about the demerits of this approach called SINR based keyless approach. So the demerits are, we are gonna summarize them in 8 points, and we have to mention that the goal of doing research in this domain and the goal of engineers and developers is always to improve these merits and decrease the demerits of the approaches that are used to provide physical air security. The first demerits, it says that Eve's S sign R must be less than Bob's SNR, which is S sign R again. So in this case, uh, there are cases where Eve's SNR, if it's closer to the base station and has better channel conditions than Bob, Eve's SNR can be better. And it might be very difficult to bring and make Bob's SNR better than Eve in this condition, unless you use some intelligent techniques. Now, when you want to use intelligent techniques, you are basically changing in the structure of the transmission. So I don't want to say this is a demerit, but you can say it's more like a condition. It's more like a requirement, a prerequisite to have physical air security. So but it's like we consider it also like a demerit, but it's like more like a condition or a prerequisite. Again, uh, this is what we mean by that. If the SINR must be less than Bob's SINR, we explain why it might be difficult sometimes to provide that. The second one is Eve's fading must be more than Bob. Again, this is also related to the signal to interference noise ratio because um, if the fading is more at Eve, it means the channel is more suppressed. And let's draw it here in a figure. So when we have channel like this and another channel like this for, let's assume this is for Bob and this is for Eve, Bob, Eve. So it says here that fading at Eve must be more than Bob. Fading at Eve, this is fading period. Fading period is where we have deep degradation in the signal, deep down degradation in the signal, which can be represented in this period. So here we have deep fading for Bob, but when we have deep fading for Bob, we try to not to transmit our data. But when we have deep fading for Eve, we assume it to be an opportunity for us to send our data, because whatever we send here, Eve's channel is really bad, so there will be a suppression for the signal. Okay. So security, the third part, security is achieved at the expense of capacity reduction. So this is also one of the disadvantages. Usually, when you want to transmit your data, especially in the case of channel coding, you have this sequence of bits. Let's say you have 10 bits, and the output has to be 20 bits. Now, this 20 bits require more bandwidth, more space, more storage, and therefore it can consume more bandwidth and can cause reduction in the capacity of your network. This is related to channel coding, and in the case of adding interference also, it can consume bandwidth because, for example, we have a technique called fading avoidance or injecting interference in the fading periods of Bob. In this case, for example, when you have deep fading period or deep fading bandwidth duration, bandwidth part in Bob's channel, in this case, you will not you may decide not to transmit over this band, and because you are not transmitting, you are not utilizing it for transmission. You are wasting it and not using it for transmission, which is a loss in the bandwidth. So this is related to techniques number one, channel coding, and number three, injection of noise and artificial interference. And for the first merit, I forgot to mention that this is related mainly to the channel coding part. There is one eye, two eye, three eyes. What do I mean by these? I mean by them here when we said enabling techniques, we said channel coding, where we gave a symbol for it, eye, and channel-based adaptation, two eyes, and injection of artificial three eyes. So here, when we put I or I2, I refer that this demerit to which technique is applicable, to which kind of approach. So when I said if the SINAR is mostly related to channel coding. The fourth demerit says that in the case of channel adaptation methods and noise and interference injection methods, they are both sensitive to channel errors. This is very obvious, very clear why we have this, because both of them use techniques that are based on the channel conditions, and the transmission is optimized and adaptive to the channel behavior of the channels. That's why we call them sensitive to channel errors, and we try to compensate for these type of errors. Now, what about demerit number 5? It says that channel adaptation techniques cannot achieve perfect secrecy. And that's right, because there will be always a gap where Eve can really decode the signal, but with it to a certain level. So you need to exploit that gap to transmit your data securely. And the sixth is the demerit following that says this approach generally is very sensitive to multiple channel observation by adversary having distributed antennas. This is very important. Now, in most our models, we assumed Eve to have only one antenna. But if Eve has multiple antennas, deploy multiple antennas, like let's say tens of antennas, and let's assume that our transmission is based on the channel of pop, and we are maybe, let's say, exploiting the diversity. Now, having multiple observation can improve the signal to noise ratio at Eve. And in this case, if it got enough number of antennas and the security technique is not robust enough against having multiple antennas, or the eavesdropper can deploy multiple antennas easily, in this case, you may not be able to provide physical layer security. Because more antennas means the Eve can aggregate more power, can improve and boost his signal. So the signal to interference noise ratio at Eve with one antenna, let's assume it was 1. With multiple antennas, it can become 5. Now 5, compare it to Bob's SINR, if it's close or the same, in this case, providing security will be difficult. So the seventh demerit is we say that noise or interference injection techniques sacrifices power resources, may increase peak to average power ratio, and it may degrade Bob's SINR. Okay, this is also an important observation. When we have noise, without the need for security, you don't need to put noise or interference or whatever. But when you want to provide security, you usually, in the deep fade periods, you add what? You add noise here. You don't random signals. These random signals don't have that data. These random signals don't have any data content. So therefore, if they don't have any data content, you are wasting that part of your resource, which can be time duration or bandwidth, and not sending anything. Instead of that, you are putting extra power that's not useful to improve reliability. So it may increase peak to average power ratio as well. Peak to average power ratio is a very important metric that we usually use it in wireless communication and wireless systems. And the goal here, if our signal exceeds the maximum limit of the peak allowed to excite a certain power amplifier, in that case, there will be a signal cut. And if you have a signal cut, it means you have distortion, you have intermodulation product, you have interference, and this causes interference at the receiver, and the receiver will not be able to decode his data successfully. And the same approach can also degrade Bob's SINR sometimes, which is very disadvantageous. Now, the last but not least, the third approach, which is noise and interference injection, requires the degree of freedom at the transmitter to be higher than that at the receiver. What do we mean by degree of freedom here? Degree of freedom, let's say you have two antennas at Eve. In this case, yes, it's true you can provide security with one or two or three, but it's always better. It's always better to have more antennas at the transmitter than those at the receiver. So, especially for the case of adding noise in the null space, like the technique in noise and interference injection. Why does this happen? And the reason for that is because when you have more antennas at the transmitter than the receiver, mathematically, when you model that your channel will be 2 by 4 matrix of 2 by 4. Like this is your channel 2 by 4, and if you mathematically try to find the null space vectors in the in a 2 by 4 matrix, you will be able to find two null spaces. When you inject noise there, you can degrade Eve's SINR significantly and improve Bob's. But if you have 2 by 2 antenna system, 2 by 2, in this case, mathematically, there is no null space, and therefore you cannot decode your signal successfully. Okay. That's the last demerit related to the keyless physical layer security approach. In the next lecture, we will continue talking about the other approach, the other category, which is called complexity-based key approach, and explain all the technical terms and all the technical details one by one, so that everybody can understand them fully and be able to develop new techniques based on the fundamental understanding of these concepts.